What's up, physics? Welcome back to the Dirt Bike Shed. Do you know what that is? That is a disc. That's a disc for a front brake on a dirt bike. And these right here, this is a caliper, and it's got brake shoes. And the brake pads squeeze that brake. Now, why do we use brakes? To slow us down. Today we're going to talk about something called momentum. Here's the formula for momentum. Okay? Formula for momentum. P equals mv. P is the letter that we use for momentum, a little p. Mass is in kilograms, and velocity is in meters per second. So when we talk about momentum, momentum is equal to mass times velocity. Now, there's no cool name for a unit of momentum. I usually just write the letter P. And what I mean by no cool name, there's no unit. It's not called a Newton or a joule or anything like that. It's just called momentum. So, momentum is equal to the mass an object has times its velocity. And that's different than force. I'm going to show you how. Here's some little Matchbox cars I had as a kid. And this is a van. And this is a Lamborghini, although it looks like a Lotus. And this is somebody you should know. I should put this in my Ed puzzles, but you know I'm going to do that. Whose car is this? Whose car is this? That's going to be in the Ed puzzle. Now, we've got a van and a sports car and a Trans Am. And you've already answered right now, that is the Bandit's Trans Am from Smokey and the Bandit. That's a 76 Bandit model. 446.6 liter big block V8. Actually, it wasn't that fast, to be honest with you. But here we go. Out of these cars, this van would be the heaviest. Do you agree? So if these cars were all rolling at the same speed, okay, then the van would have the most momentum because it's heavier. Another way to think about that, which one of these would be the hardest to stop? If we have these three cars driving at the same velocity, which one would be the hardest to stop? It would be the van because it's the heaviest, right? The van is the heaviest, so the van has the most momentum. The mass of the van times its velocity is its momentum. So, as this van is going along at a constant speed, it has a certain amount of momentum. Now, it can go faster and have more momentum, or it can go slower and have less momentum. That's what momentum is. Now, when we start crashing into each other, then we're applying forces. But when we're talking about momentum, we're just talking about something you have while you're in motion. When you actually make contact with something else, then you're applying a force. And that's a transfer of momentum. Let's try some simple problems with momentum. In real life, an old 70s van would weigh, 1,500 to 2,000 kilograms. So we're going to draw the van here. I know the van's really yellow, but you're getting green, okay? So stop. Now, we're going to say this van weighs 1,700 kilograms. Okay? So this is a real-life van. It's not a toy van. We have a real-life van. It's going down the road. And we're going to say she's going about 20 meters per second. And since it's the 70s, maybe they're talking on their CB radio. Okay, don't worry about that part. Now, momentum. Momentum equals mass times velocity. The momentum of this van is 1,700 kilograms times 20 meters per second. So I'm going to let you answer that. What's the momentum of this van? That's going to be number 2 there. What's the momentum of this van? Just take your calculator, 1,700 times 20 equals 34,000. 34,000 what? You can write 34,000 kilogram dot meters per second. That's literally the unit. It sounds crazy. If you were in class with me and everything was normal, we would call this 34,000, and I just put P. That's how I do it. All right? So, that is what momentum is. Let's do the momentum of that van in real life. There's a scale. Take this van and set it up on there. This banana yellow van. And it weighs 69 grams, 69.34 grams. Okay, no problem. Now we're going to take this van, I'm going to roll it. I can tell you the velocity right there, and I'm actually close, is about 0.5 meters per second. So the velocity of this van as it's going by is about 0.5 meters per second. So we're going to write the formula. Number 3. Go back and tell me what is the momentum of the toy van. To get the momentum of the toy van, you are going to have to give the mass of the toy van in kilograms. So you're going to have to convert that. And the velocity is already in meters per second. Okay. So we got mass and velocity, meters per second. So number 3, and go back if you need to get the numbers. Number 3 is, what is the momentum of the toy van? The momentum of that toy van as it was rolling along was 0.0345 kilogram meters per second. So now I'm going to give you some simple problems. Ready? Here we go. Number 4. Don't forget to show your work when you turn this in. Number 4. What is the momentum of these 3 problems? Whoops. Sorry about that. You've seen this board acting crazy. And there's your answer. Number 5, what is the momentum of a 2,200 kilogram truck at 26 meters per second? There's the answer to number 5. Now I'm going to switch it up on you just a little bit. I'm going to ask you a different part of the problem. What is the mass of a plane traveling at 100 meters per second with a momentum of 75,000 p? We're solving for a different part of the equation now, right? You would say 75,000 p is equal to m times 100 meters per second. We're solving for m. $75,000 divided by 100, 750 kilograms. And the last one, what is the velocity of a 1,701 kilogram Trans Am with 115,600 p of momentum? And that is true, this is real, for the 1976 Trans Am. So you'll know how fast that thing actually went. It's 67.9 meters per second, and that is over 150 miles per hour. So that thing would move once it got going, but it didn't have a very good 0 to 60 time. It was like 5.1 seconds. And the reason was the car was so heavy. So momentum can work for you and against you. So, peace out from the Dirt Bike Shed, and thanks for watching. Eastbound and down, load 'em up and truck it. We're gonna do what they say can't be done.